Hello everyone. We are going to see the topic refraction through a convex spherical surface. So to see the total refraction phenomena through this convex spherical surface, let us consider a spherical convex surface. Here suppose glass having refractive index N2 and in this medium refractive index N1 of first medium. Let this is the principal axis. Here in this principal axis, so this is the convex spherical surface. Its center of curvature C is here. This is the P. PC is called radius of curvature in this diagram. R. PC is equal to, and this side is, according to the sign convention, it is a plus. Now see, the object we are always representing in left hand side according to the diagram. Let us consider a point object is here. Object O is here. So ray diagram starts from here. So to make a ray diagram, see here one ray of light from object to the convex spherical surface. Wherever this is, at this point the normal is required to make. This normal always passes from center of curvature. So take a dotted line from here, center C. In that condition, this becomes angle of incidence I on the spherical surface. Let this is point A. Now when we saw that, when we know that when a ray of light passes from rarer medium of refractive index N1 to denser medium of refractive index N2, then ray of light turns back in same medium. So let bending towards and ray of light bent in this direction. Right? So the angle made by the normal is called angle of refraction. So point image is formed here. Let it is I. Now draw perpendicular here on it. Take this point as a EM. Now see very carefully. OP is taken as U, distance between pole to object, OP, and it is on the left side of the sign convention, so it is minus U. And we know that the U is always negative. And this distance from pole to the image is the V. So it is Pi, it is plus V. Right hand side distance taken as a positive, left hand side distance is taken as negative according to the sign convention formula. Now we are going to take some angles here. Here this angle made by incident ray with the principal axis, we are taking alpha. Image making angle, this refracted ray making angle with principal axis beta, and center of curvature this normal makes gamma angle with the principal axis. This is the diagram for convex spherical refraction. Now see the mathematical relation to obtain a mathematical process to obtain the relation between U, V, R and in term of refractive indices. First of all, we are going to take some triangles. First triangle, we are going to select AOC in the diagram. AOC. C in triangle AOC. We are knowing sum of two interior angle. This is the interior angle and I is exterior angle, third exterior angle. So sum of two interior angle, that is alpha plus gamma, is equal to I. Equation number 1. And alpha plus gamma is equal to, now we are going to take, this is another triangle. This triangle, second triangle, CIA. Children, see the diagram and the things which is written on the paper carefully. Matches with the word written here on the page with the diagram. In CIA, select two interior angle, beta and R. Its exterior angle is gamma. So one may write interior angle beta plus R is equal to gamma. Right? And by this equation we can solve for R. This implies that R is equal to gamma. Beta transfer on right hand side, it is minus beta. So in equation 1 and 2, we have obtained the value of angle of incidence I and angle of refraction R. Now this is time to see the Snell's law. Snell's law speaks refractive index N is equal to ratio of their refractive index of second medium N2 by N1. This can be written as equal to sin I by sin R. So in that condition, one may write N1 sin I is equal to N2 sin R. This is equation number 3. Now see, if in the diagram, if point A is close to M, means this aperture is very small, in that condition the angle I and R is very small, then if A is very close to point M, this implies that angle I and R is also very small. This implies that sin I can be written as I and sin R can also be written approximately as R in both cases. In that circumstances, one should be clear that The equation number 3 can be written as N1I is equal to N2R. N1 I from equation 1. This is alpha plus gamma. So putting the value of I, this is alpha plus gamma is equal to N2 R. R is gamma minus beta in equation 2. Gamma minus beta. This is now N1 alpha plus N1 gamma is equal to N2 gamma minus N2 beta. N2 beta. Now what to do with this? We are taking alpha beta one side and gamma is another side. So the term is N1 alpha, N2 beta, this minus term shifting left hand side. So sign changes, N2 beta is equal to N1 gamma shifting right hand side become, so it's become N2 minus N1 gamma. This is equation number 4. Once see all these equations, thereafter we are moving further. Now we are going to take value of alpha, beta and gamma. To obtain the value of alpha, beta and gamma, see in the diagram. First of all, we are going to take this triangle AMO. In a triangle AMO, tan alpha is equal to, see carefully, perpendicular by base. It is AM by OR. AM we are going to take as a H. H, the sign is plus because it is according to the sign convention, it is above to the origin upper side. So it is AM by OR. AM is H and OR is approximately equal to OP. If this is very small, we will take both point as a single point. So in that condition, this distance becomes minus U. If alpha I and R is very small, then alpha, beta, gamma is also small, then tan alpha can be written as alpha is equal to H by minus U. Equation number 5. Thereafter for beta, we are going to take triangle AMI and tan beta is equal to AM by MI. So here in triangle AMI, tan beta is equal to AM by RI. AM is H we have taken here and RI is plus V. This implies that if angle is very small, tan beta can be written as a beta. Beta is equal to H by V. Equation number 6. And finally, we are going to take value of gamma, and gamma can be obtained in triangle AMC. This AMC, similarly tan beta is equal to AM by RC. AM by RC, RC we will take as a PC, that is equal to the radii of curvature. This is H by plus R. This implies that gamma is equal to H by R. This is equation number 7. Now what we will do here at this stage? We have obtained value of alpha, beta and gamma. Alpha, beta, gamma. Now we are going to place a value of alpha, beta, gamma here in equation number 4. Equation number 4, first of all here is n1 alpha. In place of alpha, one may write h upon minus v plus n2 beta, and beta is h by v is equal to n2 minus n1 gamma, and gamma is h by r. See, in this expression we can take here h is available everywhere and can be cancelled. So one may write n1 by v minus plus n2 by this is alpha is h by u. So it is u, n2 by v is equal to n2 minus n1 by r. If we rearrange it, n2 by v minus n1 by u is equal to n2 minus n1 by r. This is equation number 8. This equation 8 represents the relation between radius of curvature or UV and N1 and N2 here in the diagram. Right? N1, N2, R, V and U. So this is for today only. Thank you and have a nice day.